Hi, this is lesson 2.4, using rates of change to create a graphical model. So we're going to be looking at a few different examples here and different types of graphs that we're going to be drawing here. So please read the example, and then what we need to do is decide on how we're actually going to draw this on the grid. What we're going to do is draw a distance versus time graph for phase walk to school. So of course we can then label this as distance, and that's in kilometers, and along the horizontal axis that's going to be time in minutes. Okay, so the question or the scenario is that she began her journey to school by speeding up for 30 seconds. Well, it looks as though 1, 2, 3, 4, 5. So this is the 1 minute mark. So for half of this, she would be speeding up. So I'm sure it'll be quite gradual. And so if we were to magnify that part down here, just to kind of give a bit more of a sense of this, and this is going to be exaggerated also, it's not going to be perfect. So it's going to be a curved line. So it's going to be actually not a curved line, it's going to be a curve because she is speeding up, which indicates acceleration. And then what happens is she then continues for another 7.5 minutes walking at constant pace. So 30 seconds plus 7.5 minutes would end her at 8 minutes. And so we'll just 8 minutes is about here, 6, 7, 8. So we'll say she goes up to about here. Then what happens is for the next 30 seconds, she's going to speed up yet again. And so of course that will also be a curve to show another increase. Okay, and there should have been a grid down here, grid lines, to again show a magnified view. And so again, it's going to be another curve, and that's of course exaggerated once again, but just to show that definitely there are curves here. So there's going to be a curve here when she's speeding up or accelerating at the beginning, followed by a constant pace here, and then again followed by another curve where she accelerates one more time or speeds up. And then she's going to continue at this quicker pace for another 3.5 minutes. That's 8.5 minutes, and then 30 seconds, and that'll get her to school at about the 12-minute mark. So I'll just continue this up here at a constant pace. Okay, so that's kind of how you would go about drawing a a graph like that with different segments that are described in the scenario. Okay, so that's a distance versus time graph. Now what we're going to do is we're going to draw a speed versus time graph for her walk to school. Okay, so speed, I'll write S, and this is in kilometers per minute. And then of course time is in minutes. And so now we need to sort of do we probably have to find the slope to get a correct an accurate graph here. So for this first curved portion, where it's curved on the distance versus time graph, it's actually going to be, sorry, I was pointing up here. For this curved section, it's actually going to be a straight section for this, but it'll be constant, but it'll be at some kind of an angle. So for 30 seconds. And then it's going to be constant speed up until the 8-minute mark. Okay, so because the speed doesn't change, then on the speed versus time graph, that line will not change in any way. And then, of course, for the other curve, the acceleration up here, for that 30 seconds on the speed versus time graph, Faye will be accelerating once again for another 30 seconds. And then from there, she continues on at a constant rate again. Okay, so technically speaking, I should probably have calculated the slope here and here for these two straight sections to get a more accurate graph here. But the idea is, the main idea of this is to show that any acceleration on a distance versus time graph in these two places, a curve, are going to be straight slopes. There will be straight lines. And followed by horizontal lines for the constant speed that she travels. Okay, so that is the first little section for this, this lesson here.